So here's our problem. Two cards are drawn at random from a deck of cards. If K represents a king and N represents not a king, find PKK, PKN, PNK, PNN when the first card's replaced and the first card is not replaced. Since I'm just summarizing what we did in class, I'm going to go through quickly on there. Now we set up our tree. We have two choices. We either have a king, or two possible outcomes, or not a king. On the first card. On the second card, it can also be a king or not a king. Now, what's the probability of being a king? There are 4 ways to do that, and there are 52 possible in our deck. There are 48 cards that are not a king and 52 in the deck. Now, once that card is replaced, does the probability change when we draw a king again? No, it doesn't. So this is 4 out of 52, and the same thing with the not a king. There's still 48 cards out of 52, and we could just list those down. And we have 48 out of 52. So when we're finding here P, K, K, we're just going to follow this branch down. 4 over 52 times 4 over 52, and that is 1 over 13 times 1 over 13, or 1 over 169. PKN, so we have K, 4 out of 52, and then we follow that down to the N, and that would be 48 out of 52, and that would be 12 out of 169. PNK means we're starting on the other side now. We have no king first, that would be 48 out of 52 times, once we have that one, we're going down the king branch, so we have 4 out of 52. That also is 169. And then PNN, 48 out of 52, and then 48 out of 52. And that'll give us 144 out of 169. Another way to have computed that number is we could take 1 minus 1 over 169 minus 12 over 69 twice. And that would give us our 144. Now let's see what happens when the first card is not replaced. In our first event of drawing the cards, we still have king and no king. And on the second one, king, no king, king, no king. And when we draw our king, how many kings are there in a standard deck? 4 out of 52, so just like we did before. But what's different now is since we don't replace the cards, we took 1 king away. How many are left? There are only 3. How many cards are there? 51. Over here, since we took the king out, we still have 48 not a king cards left, and there are 51 possible. When we look at it, when we draw not a king first, then we have 4 kings left, and there are 51 cards possible. And when we take not a king, that means one of those is gone, so we have 47 left out of the 51. So when we're setting this one up, I'm going to set and show you the conditional probability on that. PKK would be the probability of K times the probability of drawing a king given that the first card was a king. So probability of a king is the first part, 4 out of 52, times the probability of drawing a king given that the first card's a king. So here's the first card, a king. We draw the second one, and we get 3 out of 51. And when you multiply those out, you get 1 over 221. That's 1 over 13 times 1 over 17. The probability of Kn, that would be the probability of king, that's the first card. And now we want the second card to be a king given that the first card's a king. Well, again, 4 out of 52 is the probability of a king. Probability of drawing a not a king given the first card's a king. That would be this path here. That is 48 out of 51. And that multiplies out to give us 16 out of 221. Probability of not king and then a king. So that would be probability of not a king. And then what we'd want is probability of a king given that the first card was not a king. So probability of no king would be 48 out of 52. And now we want to draw a king given that the first one's not a king. So that'd be coming down this branch here. And that would be 4 out of 51. And that is also going to be 16 out of 221. And then the probability of no king, that would be probability no king times probability no king given that the first card was not a king. So that would be 48 out of 52. That's the first one. And then the second one we want to be not a king as well. So that would be 47 out of 51. And that would give us 188 over 221. And that's all there is to that.